G'day guys, spent all day building coils and yeah, what a day. Well, it's nearly 5:30. I was going to shut the door over here. I was going to have a lot of background noise dribble in. Okay, I'll show you this coil I made. I'll just take it off the detector first. Okay, there's really not much to see because I stuck it in one of these because I had a few of them lying around. And the only thing probably different is you see the size of the cable on that. It's very, very thick. And if you look at the other end of it, down here somewhere, you'll see it's got a little bit of extra wire there. Now, what I've done with this one, this is just tagged onto the shell here. It's not connected up to a pin or anything like that. But this is a different way to connect up the Faraday shield in the coil, and it's not like the other coils how they're done. This is completely different. The other thing too is the way I've done this. This can easy if you want to turn your an old 6000 coil and rip it apart and turn it into a dongle, which I have been known to have done wherever it is. Yeah, you can easily adapt any of these type of coils to go on a normal GPX 45 GP SD, or you can adapt it to go onto the 6000. So with the earlier ones, you don't need the dongle, of course, but the 6000 you do. So you're just going to put a little bit of jumper cable with the dongle on it. And I've had so many people message me, what is a dongle? A dongle is, if I can find that, if I can find the dongle, I'll show you. It's down here somewhere. Where are you? How about I follow the cable here off this dongled coil? No, I've taken it off. I'll put it somewhere. Oh, there it is. There it is. There it is. Okay. There we go. That's the normal 6000 coil connector. Chop. Okay. And that is a normal Minelab coil connector. Not that you have to use a normal Minelab coil connector. I mean, when you do this, you can use anything. These are probably not the best. Okay. There's better ones. There's all sorts of different grades. But anyway, on there you can see where that red and black wire is here, and this square looking thing that's taped on, that's the dongle out of the coil. So all it does is, it's just a handshake to the detector. So rather than have it all the way in the coil, just stick it up the coil lead, put it there. You can actually probably, if you really wanted to, wire it up and leave it permanently in the detector. But you can just have that. That's just rough and ready. It's just a bit of tape around it. If you want to do it nicely, do it in some heat shrink. And anyway, that's the dongle. That is the dongle. The dongle means that when the detector tries to communicate with the coil, if it can't get the signal back off this little EEPROM, it will. Well, it's a glorified EEPROM. Anyway, with a rolling code, I think. And apart from that, that is what you need to do. Like a lot of people said, oh no, it's just coil specific. No, it's not. It works on any bloody coil I stuck on it. It works perfectly. It works really well, actually. So I've put all sorts of weird and wonderful coils on it, my own standard Minelab issue coils. No problem. It works on a 6000. So, in my opinion, a lot of smoke and mirrors. In my opinion, I might be wrong, but I might be right. Anyway, with this coil here, with the big thick wire, that's very easy to change. What I've done, and I'll explain this a little bit, because I know some of you guys might want to do this yourself. I know Mr. X Coils out there who watches all the time might be wanting to do this as well. He's asking questions about DDs and why they, yeah, he's having problems with DDs, double Ds. And there is problems with double Ds. Double Ds, the way they're made, are not a very good, efficient, quiet coil. They're probably lossy, if anything, and that makes them quiet. And the only reason they're sensitive is because they've got that reactive region just like that far apart, you know, ping, ping. If it was wider and bigger, it would fall apart. It wouldn't, I mean, it wouldn't fall apart, but, you know, it'd basically not work very well. But anyway, I've basically got this wire here. I've just got it under the clamp, the cable clamp, so it is a ground, and I'm utilising this. Not very good, but I found it works really well, even though in my book of doing things properly, I've got the wire here onto the coil shell, right, the metal part, just under the clamp, just like screw it down, undo it, screw it down, it's stuck there, it's not going to come out. And you're relying on the earth or grounding connection through this little spinny nut thing that does up. So if you've got a lot of crud under the lip there or whatever, maybe it might not make a good connection. But I've done it on some of the old detectors around here. It doesn't care less. It works fine. So basically, if it actually makes you do up your detector properly if you use that. And this doesn't have to be looped up like that. I've just done that. It could have gone under there and under the clamp, right? But I've done this so I can do some quick on-off experiments and try some other stuff as well, which at the moment I won't get into. But yeah, there's this thing. It's not a very good one because I'm just moving it back and forth and a click, click. So it's got a lip in there of some sort. I don't know what it is. Can't see it. But yeah, it doesn't screw. It doesn't, like if I pull it like so, it doesn't sit square. It's that way or that way. See, it won't sit square. So something's a bit iffy. I think in the manufacturing process, something's a bit wrong or something. I really don't know. Can't really see anything. But it just goes to show how forgiving it is. Anyway, what we're going to compare this coil to is a 11-inch commander coil. So that's just a stock standard commander. It's got its coil cable cutter on there, which I think that I've actually loosened off so that little O-ring there doesn't bite onto the coil and chop the outer strands on the Litz wire. That has happened before. So I'll never tighten it. As soon as I get one of these, any of these coils, first thing I do, I'm onto this plastic bit, I undo it. Because you don't want, I mean, it's meant to stop water getting in, but don't go detecting in the rain. But, you know, just, yeah, like so. Or even get that apart, see a bung in there, there's a little rubber bung, pop it out, cut it, and put some silicon, just silicon it. Squirt some silicon in there, right? Non-acidic silicon. You don't want the thing to eat all your windings and turn them green, but non-acidic silicon, squirt it in there. And, you know, even if you want, you can actually shove tons of it in there and just carefully turn that thing on, that nut like so. Don't go do it up like freaking King Kong and, you know, guerrilla tactics. Just leave it like so and nothing's going to get in it. If you want to get technical, you can probably drill a hole in, put one of those fancy air vents in there. But, you know, do you need it? I don't know. Anyway, that's the commander coil. So what I'm going to do, I've got the old trusty no-ears sitting over there. So no-ears are sitting there. It's got variable gain on that, so I can crank it down because you know, running a mono in here, my God, it's ridiculous. But I'm going to do it. We'll try the commander first. So Commander Coden or Commander Minelab. So whatever. And I'm gonna have to do this so you can see, but I have to open the door because I actually drew some markings on the edge of the door for heights. So I couldn't do it with my ruler, it's not big enough. But anyway, hang on, we'll wind this up. And I'll turn that over there. So yeah. Oh, you want to see some junk while I'm doing this here? There you go. There's all the coil stuff, which has been crawling out. I went into the garage too. I was going to get some coil, and I didn't want to bring them in here. There's not enough room, so it just goat trails on the floor again. So we'll go around, and okay, there it is. There. I wonder, can I zoom in at the front? I don't think I can on the front. No, I can't. Damn. Okay, it is what it is. I'll just tighten that up so it doesn't fall because I left that loose. That can go tight. That's all. It's good. I've got a microphone sitting over near the speaker on this, so we'll see how we go. So we'll get Mr. Commander here, and I'll stick him on this no ears, dumb down, 4500, and we'll use normal timings just for the fun of it. I got some stuff I've got to show you on the oscilloscope too, with how fast. Well, I'll get to it and I'll explain it as I do it. If I explain it now, you're not going to make any sense. So we'll turn this thing on. Hopefully it's loud enough to hear. Should be tons of interference. Okay, so you can hear the interference come through. It's going to be interesting. Use a metal ring. That horrible, disgusting metal ring? Well, it's not really. I shouldn't say that. Okay, I'll open up the door because it's got the metal on. It's going to unbalance everything. But I've been putting marks up here. But if the door doesn't move, remember, these are motion machines. It won't care. So as long as the door doesn't move. Okay, we've got our ring. We've got our commander coil. And if I can kick some of this stuff on the floor out of the way, I mean, gently move it, not kick it. Hang on, here we go. Okay, we lost it in the noise. It's about there somewhere. It's under that little black mark, which you may or may not see. Okay, so that is the commander coil. I'll put this down to where I'm working. So turn off the detector, grab this. Okay, and we'll put the commander down here. You should not put these under your coils you're working on. They do actually talk to each other, so hopefully it doesn't. Usually if you don't move it, it should be all right. So I'll get this thing that I've used the case for, or the coil shells, stick it there, and with this nice fat thick lead, I'm going to stick it into this little beastie. And do that up fairly tight. I'll give a test on this anyway to see that if it does sound off with any movement. What I was going to do is I was going to put a tab which just goes under one of the front screws near the coil connector on the detector, and use that as an earth point with a little bit of a floating lead and little clip, metal plug type clip, just a tiny thing. So whatever, but here it is, and amazingly it doesn't sound off at all. Remember when you touch a lot of these detectors and you just move it slightly and it's whoa, whoa, whoa all over the place? I mean, I'm bending the hell out of that, no noise. So it's better in that regard anyway. Okay, back onto this thing up here, the magic door with a mark on it. There's that ring. Okay, here we go. I'm way over where that commander was getting it, a good 2 or 3 inches above. So, and there's a reason for it. First of all, I make really good coils. But there's more of a technical reason. I have to get this and show you. I'm going to wind this down, put it over near the oscilloscope, and then we'll go back and forth showing what's what and what you need to look at. I could get right into the nitty gritty, open up the detector and start looking at yeah, shut the door, thank you, there you go. That's what happens when you have the door near the coil. Okay, now I'll put this over here somewhere. I'll try to undo that. Yeah. I don't know if you can see the oscilloscope too well, but we'll have a look. Okay, we'll go back to the commander coil. So we'll just do this with the commander. So actually, this system makes you do up the nut on the coil connector. It forces you to do it, right? But when you do it, it doesn't make any noise. It's really, really good, actually. I'm really surprised about that bit. Anyway, we'll put that coil there. We'll get our commander. Put him up there. Hook him in. I might have to move in a little bit closer. Okay. Make it all tight and whatever. I'll get this a little bit closer if I can. Hang on. Jeez. Oh no, don't go in there. It's hard moving a tripod around. Okay, I don't know if you can see that very well. I should have used the other camera on this, but I'll show you anyway. We'll turn this thing on, and okay. I have to invert it. Now I'm going to have to try and put my arm under here. All right. There we go. Let's have a look at the flyback. I'll move it there. I'll just take it off where those cursors are. I don't know if you can actually see that too well. There's no way of zooming in on this front. Damn. You may have to zoom it. I can't do it. You may have to zoom it on your screens or something, whatever you're watching it at. Anyway, I'll get this under here and I'll move the cursors where the flyback is. I could probably extend it, but I don't know if it makes much difference. Anyway, here we go. That's a flight. I'll put the intensity up, burn a hole through the CRT screen, but because all this stuff is pretty fast, it's hard to see. Okay, and right on the edge there, hang on. I'm trying to get it lined up properly on right on the edge there. So on the commander coil, you can see the flyback. I mean, I'm not going to measure the curvature at the bottom, but just at the top part of it, where we've got it clamped, it's the whole basically top end of it's just over 2 microseconds, which is still pretty fast, but I'll show you a difference with the way I make the coil. So you can have a look at that, and you can have a look at basically some of the ringing and stuff like that. I don't know if you can actually see it. It might be a bit hard to see, but turn that off. Now when I made this other coil, I wound it the other way, so output's inverted, so I've got to invert it on the oscilloscope. Not that it makes any difference. Your target doesn't give us stuff if it's been hit north-south polarity or whatever. So I noticed that was very hit and miss with a lot of early coils. Some were wound one way and some were wound the other. So you got some that were wound clockwise and some of that were wound counterclockwise. And people out there made coil measuring machines measuring the output of the coil and used another coil to do it. And some coils, they go, oh, why is that coil so deaf? I said, because it's wound the other way to what yours is. So that was quite funny. Yeah, you don't realise that. Some of the older coils are wound differently. I think there's a bit of a standard if it's right hand or left hand started, which means it's counterclockwise or clockwise wound. And in the scheme of things, it doesn't make any damn difference. But if you're going to start testing outputs from coils and things, and you're using coils to do it, you'll get yourself in trouble because some coils won't couple. And the other thing is, if you're going to do that, you're probably better off just using Hall effect sensors rather than coils, because everything then becomes size reliant. If you change your test coil, it's going to interact with the top coil a hell of a lot differently. If you start using Hall effect sensors, you just got a central point. You can use that. Just get a ratiometric Hall effect sensor and run a small amplifier, just an op amp, and you get a level up so you can see it. So we'll turn this on, and I'll probably have to flip the phase, which I will. Back there. Okay. Now I'm going to go scooting around till I find it. Okay. I don't know if you can see that, but the coil's in exactly the same position, and everything's got a lot more oomph on it. That's a lot more flyback there, right? But if you notice something about the flyback energy, it's narrower in time. So the coil is fast. It's a very high Q, fast coil. That means that there is less losses. You will get more signal. So anyway, let's measure this up and we'll see where we are. Okay, right there. It's very, very fine to adjust, right on the tip there. And I'll move it in on the line. And I'll just drop that down so it goes on the top part we were measuring before, which is there. Okay, I'll just leave it a little bit above so I can fine tune it. Okay. There it is there. And there. The other one was over 2 microseconds. We're running 1.5, 1.6. So that is a substantial speed up in the energy retention of the coil itself. So I can say that my coil is faster than the Commander, which in turn, for little tiny signals decaying away at very, very high speed, I should be able to detect them better for the same size given coil. So that's that. I don't know if you can even see that, but I'll move this in as close as I can without sticking it on someone's circuit board, which I will be. Whoops! Hang on. The clip on the tripod wanted to pull the 4500 over. Sorry. Yeah. I don't know if you can even see that, but take my word on it. We go from what was it? 2.4 or 2.04, one or the other, down to 1.58 odd. So that is how fast we're getting rid of that flyback energy. It's not being stored in the windings of the detector. You don't want it to be stored, because that just proves to you that your detector coil is acting like a big capacitor and capacitors slow down fast moving waveforms. You know, you ever heard of filter capacitors? Wonder what they do. If you don't have them, your hi-fi will sit there and hum away at 50 or 60 hertz. So it's the same thing. You don't want high capacitance in your coil. You want to hear all those buzzy little sounds. Not that they're buzzy, but it's just a fast decay. So even though that's an 11-inch coil, and it is an extremely fast, I think it had a very high Q on that coil too. I remember looking at it. I remember looking at the Minelab one. It was about three point something, and my one was up around high fours. It might have been even higher. I hadn't finished it, so that's what it is. But even though I've made that coil, that's just a test coil. I have. I'll just turn that off. I don't need all that screaming stuff sitting there. But what may be of interest, I'll see if I can turn this around. No, oh, dear me. Too many knobs and levers on this. Turn it around. There we go. Oh, God. Hang on. I'm running over cables. Chairs with wheels. My God. Okay. What a day. Voice is getting better. Oh, just tap the microphones. Running the new mics as well. So that will give you an idea of a faster coil. It's not the fastest. I can make a lot better coil than that, but it gets very exotic in the materials. This is very, very, it's a good coil. It's probably better than anything out there, but I can make better, and I've got to get to the exotic stuff. And if I start making exotic coils and they leave my possession, they'll end up in other people's possession, and you know what happens, don't you? Here, have all my IP, just gift it away. That's what'll happen. The other thing I should show you too, I'll make a screaming mess again, is that with this coil, I'll just put this back on again. So it'll scream away, of course, because I've got it and there's metal everywhere. Like, you know. But just to show you, yeah, I'll hold it like that so it doesn't interact with anything. Well, it's going to interact with the chair now. But if I put my arm across it, the Faraday shielding's working perfectly, because if it wasn't, you stick your arm across it, it'll sound off. On most coils, that's picking up the tripod. On most coils, if you stick your arm across it, if you're out in the bush and you touch it like this, it shouldn't sound off, right? It just should not. You can actually search for, if you've got the carbon paper type coil, if you have it out in the bush, hold it like this, not near metal tripods like I am, because it's going to sound off. But if you get your fingers, you know, like that, and push your fingers around the coil, and if it's got any wear through on that shielding, right, you'll get that whoop 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 on that bit. So pull it apart and paint it. So that's one way to find out. That's another thing. If your coil just won't ground balance in a million years, you're bouncing it up and down, and you're just about pulling your hair out. A lot of cases, it may not be the detector; it just may be the shielding going. You know, the ground capacitance is meant. Well, I'll try and say this as simple as I can. You look at the ground as a plate or a connection of a capacitor, and it will change capacitance to anything you put near it. So, you know, as this comes in, the capacitance will change. That's what will happen. But that's why the Faraday shield's in the middle, because the capacitance is only changing between the ground and the Faraday shield, right? It's not changing with the coil windings, because it's on the other side of the Faraday shield. So I can't do anything. If there was no shield there whatsoever, what would happen is I'd do that and the detector would go, wow, it's good. And you put it on the ground, you couldn't use it, you just couldn't detect. So the coil's on, that's just near this silly thing again. But because the coil is on this side and the Faraday shield is here, well, in my case, the Faraday shield is everywhere, but that's another story. What would happen is that the coil here is, you know, shielded from the ground here. So the capacitance doesn't go through the Faraday shield and touch or interact with the coil. It just doesn't do that unless you've got a very high resistance type of shielding. So yeah. Also, you can use your coil to see if you've still got any metal fillings. No, I'm joking. It's picking up the microphone. I had all my metal fillings taken out ages ago because mercury is a toxic poison, people, and it leaches. Believe me, it does. So you had all my mercury. Fancy putting mercury in someone's mouth. Unbelievable. Anyway, don't get me started on health stuff, like breathing in toxic ABS fumes or anything like that. So yeah, that is the beastie. As you can see, it's very, very thick. And if I held up the other one, you see it was pretty skinny. But that is that. Down there we go. So yeah, I should I'll tell you what. Any of you guys who got 11-inch coils, I don't care what they are, or even a 12 or something, maybe one weekend we can go to the test site or something and put them all up against each other and just see which one wins on the day. It might be interesting. It's good to have independent witnesses on this stuff rather than just doing it yourself, because you just take my word for it. You're better off if you see it yourself and use it, because then seeing is believing. Well, seeing is believing with video, I suppose, but videos can be manipulated. That's why I don't chop the video and stop start. Like I say, if I get tongue tied or do some massive burp or a fart or something, you're going to get it on the video. I'm not going to chop it out. Just the way it is. So yeah, that's how you can make a really good coil. And I actually wish I had some scales in here, because I could actually give you a weight comparison. I don't know how it comes up on the weight. And another thing, speaking of weight, now if I said this to you guys, and I don't want to do this with a big coil, I want to do this with small coils. Say for instance, on a coil, let's say I'll pick a size, something like maybe an 8 round, 6x8 or 10 or something in the smaller category. And say if I made a coil and it was a small coil and it was twice as heavy, would that worry you? I mean, I'm only talking small things. I'm not talking about something that big, twice as heavy, because you're going to have to hire King Kong to bloody swing it for you. But on a smaller coil, does the weight, affect? Well, it wouldn't affect me. I don't care about small coils. You fill it up with lead. It's no big deal. But something like the 19-inch coil on a 7000. My God, that's pulling my bloody sockets apart. That's you got to have the bungee thing and strapped up and whatever else. I tried swinging that very early on. Right. Oh my God. Yeah, I had a sore arm for a week. No, I don't want to do that again. I thought, it's just a coil, muscle it. No way. Not good. Even though I used to go to the gym just about every day for like 30 years, it still wasn't good. Should do that again. Go back to the gym. I bought a home gym and it's been sitting up there for 3 years. I haven't even used it. That's the trouble when you buy all this exercise stuff. I have a running machine too, but I do use that. I haven't used it for about since COVID because I don't want to bring in and breathe in all that extra air which all these COVID infected people are breathing around. Oh, a lot of rubbish. But coils, weight, and on making coils, a lot of people want small coils. But there's also people who want bigger coils too, like 15-inch, stuff like that. And another one I'll run by is, would you like a coil, no matter how big it was, that it had an inbuilt pinpointer? Would you like that? You don't need a pinpointer. It'll pinpoint accurately down to a fly speck, no problem whatsoever. So if you're interested, let me know. We can do lots of things, a hell of a lot of things. What about a mono coil that is totally EMI proof, as in anti-interference, but it's a mono. It actually works as a mono. There's no other component that is wasting energy off on the side and not being able to receive properly. Would you like that? Is that a good Christmas present? These things can be done. People hear this. I know people like, you'll hear some people, will say physicists, and some engineering types will go, "Oh, you can't do that. You can't do that." Really? Okay. Can't do it, so I won't do it then. No, I've already done it. I've got a mono that is completely quiet. It just does not get affected by EMI. And there's ways to do it. What can we, just so these engineering types can ponder about it, we'll just call it capture area. There you go. And we'll throw in capture area and phase shift and see if you can work it out. You should be able to. That's pretty basic. And you can do it. Believe me, I'll put $1 million on it. You can do it because I've done it. And you can go out there for quiet mono. It just behaves like a mono. It's no detriment to the mono operation whatsoever. It just works beautifully. So let's have everyone scratching their head. I'm waiting for all these people to start making all these fantastic coils. I've given away enough information on the stuff, but yeah, look, I could. Oh, no, I won't. I just remember I've got something in the drawer. I could bring it out and show you, but I won't. We'll just say it's another manufacturer's coil, right? No, I'm not going to do it because you know what happens, don't you? If I do stuff like that, I'll be walking down the street with darts in my back or something. But yeah, like I can make these things up and show you how they all work, and I can do a lot of different things. There's a stack of configurations you can do of coils. Actually, I've actually come up for a ripper of a coil design for the 7000. An absolute ripper. My God, it will go super deep. It'll go heaps deeper than what any of them out there do, and it won't be any heavier. Actually, I think I can make it pretty light. So tell me what you think about that if I could make a super duper deep going, super sensitive detector coil for 7000. Would you be interested? And like I say, if I make this stuff up, I have no problem people bringing their coils and we just do a side-by-side test. I don't care where it is. I don't want to go all the way out the Bendigo or something like I was requested to many, many times. You've got to come up the Bendigo. I won't believe you otherwise. No, thank you. It's too far to do that. If I was going detecting for like 2 or 3 days, yeah, I would do it, but I got too much work on. There's, things that keep coming through the door. But locally, I have no problem. Just go down, down the Canadian diggings there or whatever, and or we've actually had a fellow who's got a big property up at Black Hill, where, he said you can actually come and do some detecting on his property, and put a test site there if we want to, and it's a very, very good gold area, but because it's someone else's property, you couldn't do it and let other people come. It just wouldn't be the right thing. So maybe, the one here they built a BMX bike ramp over the top of is a good enough spot. But because we're only testing target response on coils, does it ground balance? What's the sound like on this target? Throw the target on top of the ground. There's enough ground interaction. If anything was not right, it would screw it up. And someone the other day, they hated how sometimes on the coil on the testing with very, very tiny targets that I'm doing this instead of doing that. The thing is, there's so much damn background noise in here when I'm trying to do that stuff. Sometimes you can't even hear it. So if you're doing that, you might hear it as it goes over the windings, and you can't hear it in the middle. But by doing that, I'm doing it, with whatever coil, and it is what it is. It can hear it. Get rid of all that noise. Yeah, you'd hear it out in the bush doing that, but it's just to prove a point. It's if the coil wasn't working, it's not going to pick it up doing that either. It's just not going to work. So if it's fields here and it interacts with the field there, well, it's going to do it out in a gold field. Don't get your fields muddled up. I'll tell you a true story. This is just a tag on funny one, right? Actually, when I think about it, I nearly burst out laughing, right? Because a fellow once who was dabbling around with detectors rang me up, and he said he's really increased the performance of his detector. And I'm pretty sure it was a GP Extreme at the time. And he told me that he put field effect transistors into the detector. I hope he's not watching. He'll freaking want to kill me. He put field effect transistors inside the detector, right? And I went, what do you mean? And he goes, no, they're field effect. It gives greater field or something to do with it. He thought it had actually something to do with the gold field, that if you put field effect transistors in your detector, it would have an effect on the gold field, right? And, oh God, they're all the bloody same. It's a whatever it is, bloody MOSFET, JFET, bloody whatever. Field effect transistors, they're all field effect. They're all work on an insulated spacing inside there for the gate to the rest of it. So field effect, not the bloody city oval, like a field, or the farmer's paddock effect or something. I tell no lie. That's what was said to me. I just went, oh yeah, right, oh, very good. And he was telling people that he could change the transistors in their detector to field effect, so they get a better effect in the field. Because I said that, he's going to know that I'm talking about him. But hey, you said it, not me. You said it. Oh dear me. So that's quite funny. That's just one of the funny things that has popped up over the years. That's going back a while, but that's going back between 12 to 15 years ago. So hopefully he's given up detecting or dabbling or whatever. It was quite funny. Now, there was something else too. What else was there? Something I was going to say about something. Oh, get back to that big blow up that happened, you know, where someone got a detector and it all went pear-shaped and it ended up in other people's hands. And I don't know, and I got it back and I just put it back to normal and it was all going. And I had repercussions from that, that someone was going to drop their detector in, and because they saw all that hullabaloo on the website, they got scared off. They didn't want to do it. And I'm not going to say any names, so, you know, rest assured, secret. But they got really, really cold feet over it. And like I knew the dust would settle and the truth would eventually come out. I now have that detector here. There it is there. Thank God the label's down. To do. So we'll do a really good job on that. You betcha I'll bloody triple check it. But, you know, the thing is, a lot of times with these detectors, sometimes you open them up and you just say to yourself, well, you know, I'll check everything and there'll be something that you've touched or whatever. And normally where it is, it's in the coil wires that go onto the coil plug or the receptacle, socket. It's a socket with pins. It's, I don't know. It's not a socket, it's not a plug. Think about it. A socket with pins. Sockets have receptacles. But anyway, plugs have pins. You ever look at your power connector on a GPX and look at your coil connector, and they're both plugs, but they're both different. One's got pins, one hasn't. Work that out. So what is it? Maybe it's a pocket, like a plug and a socket together, or something. I don't know. Anyway, those wires under that heat shrink, which is a bane of my problems I have, that the wire is in there. It's a dry joint. It's not soldered properly, and it's held on there with the heat shrink. And it just does that or that, and it makes and breaks, and, you know, you can disturb that, and your name's mud. What I usually do, first of all, nowadays, I get in there with a knife and I cut all that bloody heat shrink away, and even if it looks like it's good, I resolder all those connections, because I'm not going to say 9 times out of 10, that's probably being a bit too greedy, but we'll say 1 time in 10 there'll be a dodgy one in there. So just not soldered properly. It's just like, no, high speed with the iron, dirt, next. No, you didn't leave it on long enough. I've had some that just fall out. They're held on there with the heat shrink tubing, and you cut the heat shrink and the wire goes up, and the wire's all tinned up, and there's a little dab of solder on the outside of the connector pin, and there's no solder in it. It's just completely, you know, missed the boat. I don't know. It's weird. So if I you know, was going to go on a serious prospecting trip, first thing I'd do is pull my detector apart and check stuff like that. You know, especially the older detectors too. Sometimes you get onto them, and especially if they're really old ones like the SDs and some of the early GPs that's still being used, that you open it up and it's holding by one strand of wire out of whatever, 20 or whatever, and it's just been like that, and it's ready to go dunk and break, and you taking the back off and it goes dunk, especially on SD 2000s. The amount of those that I've had, the power wires just go bonk and fall off, unbelievable. Just holding by a strand or a couple of strands. And in some cases, they're just sitting there, and it's like the rubber, which it is rubber from those detectors, is actually, you know, decayed a little bit, hanging on the circuit board, and it's just holding the connection there, and you touch it, just goes, boop, falls off. So yeah, there's a lot of stuff to be wary of. Like, you know, if you're going to go out and you're going to go 2 weeks into the Pilbara or wherever, somewhere whoopee whoop whoop away from anywhere, and have a think about it, how much effort you put in to your motor vehicles to make sure they don't break down, right? New fan belts and, check the radiator, backflush it, do this oil change, tighten things up, go over it, even the coolant lines, change them over just in case to new ones. You do all this work. What do you do with your detectors? Nothing. So you can drive out in the middle of nowhere, detector fails. It's always got me, that has. I mean, yeah, just pray it keeps working, that all that vibration on the road hasn't busted all the wires off. But it is common. Even the mylar, or they call them connector strips, which I just call them, basically they're a flexible circuit board. That's all they are. But they're made of a mylar type material. And so many of those, the audio comes in and out, really. It crackles on and off. Okay. Yeah. Get the mylar strip, pop it out, hold it up to a light, and just give it a slight bend and look through it. The friggin' see air. It's just sitting there like this, and it bends. It goes like that. It's common. It's really common. So you should always takes a wire with you and a soldering iron and a number 10 Torx bit, so you can pull your detector apart and fix it with jumper wire when they break. It's very common. We replace heaps of them. You can probably talk to any Minelab dealer too. I bet you they replace heaps of those as well. So, yeah. I could write a book on what you should do with these detectors before you go out. There's tons of info over the years. Absolute, yeah. I reckon I could write thousands of pages on any part of any subject. But yeah, usually too busy. So it's at the end of the day, so that's why I'm doing this. But yeah. It was a thing about coils, and I should walk out into the garage and show you my big experimental coil collection, which has been done over umpteen years. The last time I had a coil. I pulled it out, it'd fallen down the back, and I put my hand down and grabbed it. I freaking nearly put my hand on it. It's a massive redback spider about the size of a 5-cent piece, and yeah, used the coil for its home. And yeah, I wasn't impressed. So I've let off a few bug bombs in there. Hopefully that fixes their little red wagons or their little red stripes on the back. Anyway, there we go. How's that? Got right off the subject talking about coils. And you probably noticed too that the weather's warming up now. It got up to a nice 20 degrees Celsius today. And yeah, no heater on, no background noise. Fantastic. So hopefully I can finish off all my work. I want to get out and do some testing. I've got some areas I've got to go and do. I've had people offer me to go and do areas. We've even got our own big block of land over at Frenchman's, which is a company block, but we can, it's actually freaking loaded with gold in that area, but around Barclay, Frenchman's, Moonambell. Have a read up of the history of Moonambell and 10 Mile and 5 Mile, richest alluvial patch anywhere in the world, right? Only was attacked for about a year or two until the Castlemaine diggings sprung up. Found gold at Castlemaine, and everyone left, and that was the end of that. It hasn't been touched since. And they never found the source of the alluvial gold. And we'll call it alluvial nuggets. So all that area, the people there are going to hate me, aren't they? But all that area, yeah. And by the way, it's absolutely chock-a-block full of snakes. If you go to a place where you want to go, here we go. I'll give you a giveaway area. If you find out where the CO2 carbon sink is in Frenchman's on Google Earth, believe me, you won't miss it. Look for the words CO2 sink, right? Anyway, carbon sink, or I think it's CO2 sink. But anyway, think of a big forest and how you could see that from the air. But you'll see it. Anyway, get in the little hills behind that, and there is a stack of gold in that area. But be wary, it is full of bloody brown snakes and black snakes, and the odd red belly black snake as well. It's all I've ever seen there, but yeah, the brown snakes, they're freaking vicious around that area. Be careful. What I do when I go to those areas, always, if I can, I thump the ground really hard where I am, and before I move off, just bang the ground. Like if you had a big piece of wood or something, just smack the ground. Put low frequency thump vibrations into the ground, and the snakes will scatter off. On a warm day, they'll scatter off. They don't want to get attacked. They'll think something big's come to get them. They'll nick off. And as you move into a different area, probably every 20, 30 meters or something, do the same thing. Just big bang, bang, bang on the ground, and it'll scare the snakes away from where you are. Yeah, but make sure you take something you can thump. Maybe your pick will do, but it's too sharp an edge on a pick. You want something that's flat, and you can really put a lot of energy and make a low, powerful vibration into the ground. Snakes hate that, and usually won't hang around, but occasionally some are caught up asleep and they just don't care less. That's weird, but watch out for that too. Some little ones, they don't react and they just stay coiled up, and very easy to step on. Be careful. But yeah, always get some good snake guards on your legs just in case. And remember too, when you bend down digging, don't stick your posterior into unknown territory, or don't dig into unknown territory without inspecting it first. Always take something like a long stick or something, just attach it to your detector shaft, and if you're a bit wary, right, maybe if you push your detector coil in there and it's on vegetation, it may not touch what's down there, like slippery Sam snake. If you get a stick you can poke through, and if there's a snake there you'll know about it, you can back off pretty quick. But just be wary, guys. It's snake season here in Ausland, well, especially down our way. And when you're in a city like Ballarat, and about a week ago there was a tiger snake squashed on one of the roads in a city. Where'd that come from? If it's slivered in, there's snakes around, and if someone put it there, well, that was a crazy joke. But all good. Yeah, anyway, I'm back into, I think I've got to do some work actually. I still got that to do and that to do. So I'll be doing some detectors, and at least I done a coil which can be used, tested and compared. But I can tell automatically or just by observation, that just the effects I'm getting on the oscilloscope from that coil, it's a far better coil. And it will be far more sensitive, even though it's 11 inch, and it will go deeper because of the sensitivity. And because of the way I made it, it's going to have less, it will have less ground interaction too, and it will have less effect to any sort of mineral pockets that change as you go over it with the coil. Anyway, I really should let people play with my coils and see what they think. That's the gist of it. So anyway, oh, look at that, 59 minutes of waffle. And yeah, and the voice didn't give out. Fantastic. Catch us later, guys.